Hey everybody, my name is Abby, and I'm going to be taking you through how to do sprint number 20. So this question says, compute the number of positive divisors of 10 to the power of 10 that themselves have at least 10 positive divisors. Now, we know the prime factorization of 10 is 5 times 2, so the prime factorization of 10 to the power of 10 is just going to be 5 to the 10 times 2 to the 10, right? Now, in order to solve this in, I'll say, the simplest way, we're going to want to be familiar with the concept of complementary counting, which in our case basically means finding the number of positive divisors that don't have at least positive divisors and subtracting that from the total number of positive divisors. So basically finding the opposite of what you want and subtracting that from the total. Now, since this is the prime factorization of 10 to the 10, we know that the number of total positive divisors 10 to the power of 10 has is 10 plus 1 times 10 plus 1, or 11 squared, which is equal to 121. Right. So let's say we have a positive divisor of 10 to the 10, n. We'll just call that n. Then we know that n's prime factorization has got to be in the form of 5 to the power of something, say I, times 2 to the power of another number, say j, because those are the only prime factors of 10, right? And that we know if we want the number of positive divisors that n has to be less than 10, then we want I plus 1 times j plus 1, all of that to be in total less than 10, which means that this expression can have a value 1 through 9, right? If we want this to have a value of 1, then I and j can only be 0, so there's only one possible pair. If we want it to be 2, then we could have a value of 0 and a value of 1 for ij, or the other way around. So there's actually two possible pairs. If we do this for every number 1 through 9, we get 1, and then 2 for 2. For 3, there's 2 pairs. For 4, there are 3 pairs. For 5, there's 2 pairs again. For 6, there are 4 pairs. For 7, there's 2. For 8, there's 4. And then for 9, there are 3 pairs. These are all the possible pairs of numbers that we can have that would give us a prime factorization that gives us less than 10 positive divisors. Add all these pairs up, that's 23. We know that 10 has a total of 121, so if we subtract this number from our total, we will get our answer, which is 98 positive divisors.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.